Why choose SQL versus NoSQL in system design? Hello, everyone. Today, I'd like to walk through how to choose between SQL and NoSQL in system design. This is one of the most common decisions, but also one of the most misunderstood. It's not about which database is better. It's about choosing the right trade-offs for your system. When evaluating SQL versus NoSQL, I usually break it down into 4 dimensions. First, concurrency and throughput. Second, query complexity. Third, transaction requirements. And fourth, scalability strategy. Let's go through them one by one. Concurrency and throughput. Let's start with SQL databases. SQL systems like PostgreSQL or MySQL provide strong ACID guarantees and mature concurrency control mechanisms, such as MVCC and row-level locking. They scale reads well through replicas and ensure correctness under concurrent access. However, write scalability is often constrained by a single primary node, and heavy write workloads can lead to lock contention. So the key idea is SQL is strong in consistency, but limited in write scalability. Now let's look at NoSQL. NoSQL systems are designed for horizontal scalability from day one. They support built-in partitioning and sharding and are optimized for high write throughput, but they often rely on eventual consistency and may require data duplication. So the key idea is NoSQL trades strict consistency for scalability and throughput. Query complexity. SQL databases excel at complex queries. They support joins, aggregations, subqueries, and window functions, all powered by mature query optimizers. This makes them ideal for analytics, reporting, and complex relational models. In contrast, NoSQL databases have limited or no join support. They rely on denormalized data and require query patterns to be defined in advance. So the key idea is SQL is query-driven, while NoSQL is access pattern-driven. Transaction requirements. SQL databases provide strong ACID guarantees. They support multi-row and multi-table transactions with strict consistency and reliable rollback. This is critical for systems like payments, inventory, and financial transactions. So the key idea is SQL is the default choice for correctness-critical systems. NoSQL systems typically follow a base model, favoring availability and partition tolerance. Some systems support limited transactions, but not at the same level as SQL. They are better suited for social feeds, logging systems, and telemetry pipelines. So the key idea is NoSQL prioritizes availability and scalability over strict consistency. Scalability strategy. SQL databases traditionally scale vertically. Horizontal scaling is possible, but sharding introduces significant complexity. As the system grows, operational overhead increases. NoSQL systems, on the other hand, are built for horizontal scaling. Partitioning is simpler, and they fit naturally into distributed architectures. So the key idea is NoSQL is designed for large-scale distributed systems. Real-world decision. So how do we choose? If the system requires strong consistency, complex queries, and transactional guarantees, SQL is usually the better choice. If the system is write-heavy, globally distributed, and highly scalable, NoSQL becomes more suitable. In practice, many systems adopt a hybrid approach: SQL for transactional data and NoSQL for high-volume or denormalized workloads. Summary to summarize: SQL excels at correctness and complex queries. NoSQL excels at scalability and high throughput. The decision depends on consistency requirements, query patterns, and workload characteristics. Closing insight to conclude. The decision is not about SQL versus NoSQL. It is about choosing the right trade-offs for your system. Great system design is not about picking one technology, but about aligning your data layer with your business needs and growth trajectory. Thank you.